You can't silence a noise by covering it up.
You can still hear the music box. That's because the vibration is still travelling into the table.
It's much better to cover it and insulate it from the table. But you may still hear it, because it's much harder to silence noise without removing the source. From trains to traffic, planes, and more, cities are incredibly loud.
Often people will blame themselves for not being able to hear correctly in a space, but it's often the result of poor design.
New York City is one of the loudest cities in the world. So, we asked acoustics expert Raj Patel to explain how metropolises like New York City can actually quiet noise pollution, and whether it could ever stop being so loud. If you could design a city from scratch, the best solution to traffic noise would be to separate busy roads from areas where people live or work. Since that usually isn't an option, a more practical option is to separate these areas by reshaping the city's surface or adding barriers, like designers used in the 1850s when they built New York's Central Park.
As you come into the park, you drop quite significantly by about 10 feet. This wall helps to reflect the sound from the street back away from the park itself to try and create a calm environment in the park.
Because of this, the park is much less noisy than the street. Historically, experts recommended limiting environmental noise exposure to 70 decibels, averaged over a 24-hour period. It isn't enough to just line roads with a thin layer of trees or plants. Sound can go straight through. It's important to modify the terrain.
We improve over the at-grade flat scenario by creating some mitigation of sound here, where we both absorb the sound and we reflect some of it back out to over the highway. It still means that some of our sound sources travel straight through here.
You can even take this a step further.
In this scenario, we've changed the grades between the road and the building. We've improved the situation of the barrier, which is sending sound back out towards the street.
But sometimes the situation is much more complicated. Like when Raj's team helped design Little Island, a park directly off Manhattan's West Side Highway.
It's located right next to an industrial site here, adjacent to a large construction site. You have 4 lanes of highway running all the way through.
So they planned the shape of the island and its plants to block sound from reaching key areas of the park, like its main lawn, playground, and performance spaces.
The wind coming through the trees create a backdrop that starts to mask the sound of the West Side Highway, and the sound levels reduce further as you go towards the west. It was an opportunity to bring some of the key learning from the design of Central Park and use similar principles to try and achieve optimum sound conditions in the new park.
Fixing a city's noise problem also has to consider sound below street level, in the public transit systems. As cars move at high speeds on these rails, the whole system creates noise. And it's not just a problem for people on the train platforms.
The wheel-rail interaction in a subway system results in vibration travelling through the tunnel. It then travels through the ground to the footings of nearby buildings, and then travels up through the building as vibration, and then that energy converts into sound.
This is why some people who live above subways can hear and feel rumbling as trains go by. But it doesn't have to be this way. Engineers can counteract the loudspeaker effect by insulating the tracks from the ground. Raj works for a firm that helped to design New York City's 2nd Avenue subway extension. What they did was attach the rails to resilient fasteners that minimize how much vibration reaches the wider system.
It's a squishy material that's designed to absorb the vibration of the rail before it travels into the surrounding track slab. When completed, it looks like this.
Another important fix is adding sound-absorbing treatment to stations. Train platforms are typically constructed with concrete and tile to make them durable and easy to clean. But these materials also reflect sound and make track noise significantly worse.
So this project, 96th Street Station at 2nd Avenue Subway, incorporates sound-absorbing treatment located between all of the beams here. So any sound that reflects from the walls is directed towards the ceiling, and any noise from the trains themselves also gets absorbed in that location.
There is a Local 7 train.
Improving train acoustics is also important so passengers can understand announcements.
In an ideal world, speech is clear and intelligible.
Please allow all passengers out of the train.
As we add reverberation in a room, that word becomes harder and harder to understand.
Please allow all passengers out of the train.
The other impact is noise. A little bit of noise is okay, but the more noise you have, the more difficult that becomes.
Please allow all passengers out of the train.
Add to that reverberation,
Please allow all passengers out of the train.
and you start to get a significant problem.
But lots of the time, the noise that bothers people the most doesn't come from permanent infrastructure. It comes from construction or other people.
The sounds that people tend to find most disruptive are either repetitive and impulsive, a beat that keeps on repeating itself over a period of time, or things that are very tonal, so they have a single pitch and a single sound that continues for a long duration. Our ears are most sensitive to sound where most of the information in speech is contained, and that's between about 500 Hz and 2 kHz, which is somewhere between the middle and the upper 3/4 of a piano keyboard.
As cities grow, it's increasingly important to manage noise levels. Because so many different things are happening in a city block at once, it's important to understand how a project will affect its neighborhood and how surrounding noise will impact it. Arab simulates the acoustics of future projects with a facility called its Sound Lab. It immerses clients in spaces that haven't physically been built yet.
We use this to listen to almost every project that we design now.
In the case of Brooklyn Steel, a concert venue in New York City, for instance, it helped the venue figure out how to convert a former steelworks factory into a massive music venue.
Almost all of the wall surface in this building is covered in 2-inch thick sound absorbing material. By having good room acoustics, that means the sound engineers in the building don't have to push the sound levels higher than they need be to combat reverberation in the room. The second really important component here is the sound system. A line array is designed and electronically controlled to beam sound directly to the audience where you need it, and to ensure that no sound goes where you do not need it.
They also added a 1-foot perimeter wall around the performance space, and only one side is an exterior wall. They also added a roof 4 feet above the existing roof, and covered it in grass and plants, which further insulates noise that could otherwise escape. Similar roofs have been built in many sports arenas, from Barclays Center to the University of Notre Dame basketball stadium. Noise pollution can have a huge impact on health and quality of life, causing stress and increasing risk for heart disease and other issues. But while engineers have more and more tools to address the problem, some cities may need to write and enforce standards so these tools actually get used.
It requires a proactive approach to thinking about how buildings and people exist in harmony with each other, and how you make noise and acoustics an integral part of that thinking.